Okay, students, so now these problems are related to 6.6, which is polynomial inequalities and rational inequalities. This is a polynomial inequality, and I'm just going to talk about this. First of all, it's an inequality. Let's put this in the form of, let's move all of the terms to the left. Now remember, change side, change sign. Okay? Right? We just subtracted those two terms from both sides. Now, notice here that we've got three terms, and it looks like we could factor something out. So let's factor the what out? The x squared. Don't forget your factor training wheels if you need them. If we're factoring an x squared out, what times x squared gives me 9x squared? Be 9, correct? Alright, now we're going to have to chew this down a little bit more. So let's see, we have x squared. Then I wonder if we could factor this out. Well, how about 2x and x? Now we happen to notice here the sign is minus, so they're opposite. I'm just going to put plus minus. I'll change it later if I need to. Alright, what we're looking for is we're looking for factors of 2 and 9 that will give us 3. If I put a 9 there and a 1 there, that's not going to work. If I put a 9 here, that's 18 and 1. That's not going to work. How about 3 and 3? Okay, now keep this in mind. This is 2x squared. That'll give us a minus 9. Now what is this? This is minus 6x and plus 3x. Listen to yourself. Minus 6x and plus 3x. Okay, so that is what we want. Alright, now we have actually 4 factors. We have 1, 2, and then x and x, okay? But I'm just going to, well, let's just write x and x. Okay, well, now let's find our critical points. Well, this one's easy, that's 3. This is going to be negative 3 halves. This is 0, and that's 0. Well, since the 0 is happening twice, let's just say 0 one time. Alright, now remember how to do this. You have your number line. Okay, we're going to put negative 3 halves here. We're going to put 0 here, and we're going to put 3 here. Now what we need to do is we need to come up with some test values. Since that's negative 1 1/2, I'm going to say negative 2. I'm going to say negative 1. I'm going to say 1 and 4. Okay? Now, you could put your test values way in the world back up here, but I wouldn't. Let's start with something easy like the 1. Put 1 here. You're going to have a positive, a positive, a positive, and a negative. A positive, a positive, a positive, a negative. When I multiply all of those out, I get a negative. Okay, that's going to be a negative. But I want something greater than 0, which is a positive. So this is false. Okay, let's try that again with the 4. Now watch what I do. Here's the 4. I'm plugging them in here, okay? That would be a positive, positive 4, positive. That would be a positive, and that would be a positive. Everybody's positive. Hey, we're positive. Multiply them all together, and it's a positive, which is what we want, so it's true. Now, having done this a few times and working with a lot of students through the years, that is probably the easiest way of doing that. So true, false. Now we got to check this one out, a negative 1. Okay, a negative 1. That would be negative. I'll put it down here. That would be negative. That would be negative. That would be negative 2 plus 3. That's positive and a negative. Well, that would be an odd number of negatives, so it's negative. I'm looking for something positive, so that's false. Alright, negative 2. Okay, let's put it in here. That's a negative times a negative times, that would be negative, and then the last one would be negative. That would be a positive. The product would be positive. That's what we're looking for, so that's true. Okay, now that was a lot of work here, but so here's our situation. We know it can't equal 0, so open circle here, and to the left and to the right. What does that mean, writing in interval notation? It means there's two portions here, negative infinity to negative 3 halves, remember not included, so parenthesis, union 3 to infinity. And there's your answer for example number 1. Okay, so again, polynomial inequality, try to put it in a form that we can use, factored it out, picked some test values, plugged them in, see if they were true or false. If it's true for one portion of the region, we got 4 here, right? 1, 2, 3, 4 regions, okay? Let me show you that to you so you don't miss that. Okay, we have 4 regions of the number line. This region, region 1, this region, number 2, this region, number 3, and this region, number 4. Okay, so that's example 1. I hope that maybe cleans some things up. Now, let's move on. Okay, this is a rational inequality from lesson 6.6. Now you probably may want to just, jump right in there to this problem and work on it. But we need to think about it briefly. First of all, we do have critical values. Second of all, we know that your denominator cannot equal 0, so it can't be 1. And we're looking for something that is greater than or equal to 0, or on the water or above the water. Okay? Got to look at the video for that to make sense. So right now your critical values, what are they? They are 4, negative 2, and 1. We're still going to use that 1, but you'll see how we do this. Now, let's just draw a number line, and I notice that the most negative number is negative 2. I have 1, and then I have 4. Okay, so notice our regions. We got region 1, region 2, region 3, region 4. Let's come up with some test values. How about negative 3,000? No, negative 3. How about 0, 2, and 5? Okay, unless you like making life harder on yourself, just do that and you'll be okay. Now what we're going to do is we're going to plug in these values, but we're just considering the sign. So watch what I do here. That's like a little division bar. Okay, and we're going to plug in the numbers. We're going to start with the easiest one first. Let's plug in 0. If I plug in 0 for that factor, I get a negative 4. Let's just say negative. 0 over here would be a positive. Divided by a negative. That's a negative divided by a negative, which is positive. Okay, is that what we want? Yes, you want a positive. So this region right here is true. Okay? All right, let's do the 2. If I plugged in the 2, that's going to be a negative times a positive over a positive, which is a negative over a positive. Sorry about that. Which is a negative over a positive, which is a negative. Is that what I'm looking for? No, I'm looking for a positive, so that's false. Let's go to the 5. I'll plug in a 5 there. 5 minus 4 is 1. It's positive. Put a 5 in there, that's 7. That's positive. Put a 5 over there, that's 4, which is positive. And a positive times a positive over positive is positive. Is that what I'm looking for? Yes. So true. True, false, true. Now, you may think they toggle or cycle, but that's not always true, so keep that in mind. Okay, I'm going to go over here. I'm not too good with this technology yet. Alright, so negative 3. Let's do negative 3. Negative, negative, that would be negative times a negative over a negative. Because that would be negative 3 minus 1 is negative 4. Well, negative times a negative is a positive divided by a negative is just negative. Now what was I looking for? I was looking for a positive, so that's false. Alright, so let's see. It's true here. So it's true between here. Now, let's see. The negative 2, could it be 0? Yes, it could be 0. Now, I got 1. Well, 1, we have a problem with the 1, so I'm going to put an open circle. Right? Because you can do 0 over 1, but you can't do 1 over 0. Alright, that's false here and true here. Now, can the net value be 4? Yeah, it could be 4. Alright, so this is a good little review type question. How would you write the orange graphed solution set as an interval notation? Well, I have 2 parts, so it's union. And let's see, what do I have? My endpoint there is negative 2, and it stops at 1. Now, can someone tell me why we put a open circle on negative 2? I have no idea. It should be a closed circle. So that should be a bracket, and that should be a parenthesis, because that is included and that's not included. Alright, how would we show that? A bracket at 4 goes on forever. Okay. We put a parenthesis here because you can't go past infinity, unless of course you're Buzz Lightyear, to infinity and divine, and not divine, but and beyond. Okay. All right. So there are 2 examples here of how to work those problems. They could get more complicated, but our mission was to understand them first, and hopefully that helps you out. So best wishes with that now.